Dear students, the next question from 11th standard unit and measurement chapter, Ncert exercise problem 2.8. Okay, see the question here. Some question is given in three different ideas. Okay, so actually what we learn from this question, we feel sometimes this reading is not possible. Okay, say for example, let's take one meter scale. Okay, so by using this meter scale, we can measure the length of this pen. So here 13.8 centimeter will come. Okay, right. Somewhat we can measure this length of this chalk piece, so that is also possible. Here 2.5, 2.8 centimeter will come, so that is also possible. Okay, so but now what I'm asking, I want to measure the thickness of the hair by using the meter scale. Okay, so it is highly difficult, but possibility is there. Okay, so whether the possibility is available is there or not, so that kind of questions only we are going to discuss. Okay, so we discuss one by one. Okay, see that, and then some apparatus also. For example, vegetable. You are asking 1 kilogram of some vegetable. They are using some particular machine. Okay, so the weighing balance. So we can get 1 kilogram some vegetable. Okay, but the same machine we can't using for to measure the joules of. Okay, because that accuracy will be different, that the least count will be different. So that kind of questions also here available. So let's discuss one by one. See the first one, you are given a thread. Okay, okay, and the meter scale. Okay, meter scale. Okay, then how will you estimate the diameter of the thread? Diameter of the thread. Okay, see that. So diameter of the thread up to. Okay, that means thickness. Thickness only, the diameter of the thread. Okay, so then how to measure? But suppose if I use screw guards, what will happen? So here two jaws it will be compressed on another, so we didn't get perfect value. Okay, so without disturbance only we want to measure the diameter of the diameter of the thread. Okay, so it is possible, is there? So we know very well. If we are asking the length of the thread means, okay, easily we can measure. See that it is 1 meter like this, half meter like this. Okay, but now they are asking the diameter of the thread. Okay, so if I use the diameter, I didn't get the proper value because this is less than 1 millimeter. But here minimum reading is 1 millimeter. Then how to find? Okay, so that is the trick from this question. Okay, so whether possible or not, we are asking question, no, it is biased, it is possible or not. That is explained by the this question number 2.8. So we can solve one by one. Okay, first let's take the A question. Okay, in the A question, thread and meter scale is given. They are asking then how to estimate the diameter of the thread. Very simple. Let us take this meter scale. Okay, suppose you don't have meter scale means let's take this kind of cylindrical bar also. Okay, so here let us say this meter scale. So we have to wound. Okay, we have to wound this thread on the meter scale. Okay, thread on the meter scale. Okay, so like this. Okay, so let's imagine now this is a meter scale. Okay, so it is wound like this. Okay, this amount. Okay, but here if you observe the diagram, some gap is there in between the thread. Okay, in between the next consecutive thread, some gap is there. But here there is no gap here, so then only we can measure the diameter. Okay, for explanation purpose, little gap is here, so then only you have to understand, or otherwise how it is. Like that only will come. So you can't do it, is not visible anything. Okay, so right. So say for example number of turns counted on the scale. So the number of turns counted on the scale is there is n. Okay, then the length of the scale it is covered x centimeter like that, or x something. Okay, so now we can say, now we can find what is that? So diameter of the thread, diameter. So the diameter of the thread is equal to total length divided by number of turns. Okay, a covered length divided by number of turns, of the thread. According to my convenience, okay, maybe it is 100 or 1000 or 2000, so like that. Okay, this possible means minimum at least 100 is good. Okay, so now I can write that the length covered, that is x value, then divide by number of turns is n. Okay, see that in this question you are given a thread and the meter scale, so they didn't say any reading. My convenience, I will take x is equal to, okay, x is equal to whatever cover with the width. So that the number of turns is 100. So I can write x divided by 100, that's all. So easily we can find actually this x centimeter is nothing but total n turns of wire diameter. Total n diameter. But I need one diameter. So that is x divided by 100. Okay. This is the way to find diameter of the thread. Okay. See the next one. A screw gauge has a pitch values given, that is 1 millimeter, and 200 division on the circular scale. Okay. Do you think it is possible to increase accuracy? Possible to think to increase the accuracy of the screw gauge arbitrarily by increasing the number of division on the circular scale. Okay. Now screw gauge. Generally, screw gauge least count, that is this solution for B question. Okay, screw gauge least count, that is 0.01 millimeter. This is generally. Okay, but if you observe that here the pitch value 1 millimeter, but the circular scale, number of scale division is 100 actually in the given screw gauge. Okay, but in the question they said 200 division in the circular scale. Okay, so if you increasing that number of turns in circular scale instead of 100, 200 means what will happen? I think what is it? It's possible to increase in accuracy. Accuracy increase ஆகுமா அப்படிங்கிறது first question. அதுக்கப்புறம் arbitrary by increasing the number of division on the circular scale. அப்படி increase ஆகிட்டே போயிட்டு இருந்தா என்ன ஆகும்? Okay? Okay, maybe it's 100 or 200, 300, 400, 500. If increase means what will happen? So that is a question. Okay? Like, so actually this you know how to get. So LC least count is equal to pitch value divided by number of head scale division. So pitch value actually what 1 millimeter divided by actually we are using in the laboratory. Here number of head scale division is 100. Okay, so we are using 100. So this answer only least count is equal to 0.01 millimeter. This is we are using in the laboratory. But now instead of 100, we increasing the 200 division. So what happened? See that. So least count is equal. Pitch value no change. The same 1 millimeter alone. But head scale division is 200. Okay, so what happened? So least count is equal to, here 1 divided by 2. 1 divided by 2 is nothing but 0.5. Here 1 divided by 100 is there. 100 is moving numerator 10 power minus 2. So 10 power minus 2 millimeter. So least count is equal to 0.005 millimeter. See that? This one 0.01 millimeter, but this one 0.005 millimeter. So here accuracy is increased. Here very minimum reading is 0.01 millimeter only. But here 0.005 millimeter. So what happened? Accuracy is increasing. Accuracy increasing. Accuracy increasing, okay. But how to take the reading? Okay, even in the laboratory we are using number of critical division 100 only. Okay, even the 100 divisions also sometimes we are using magnifying glass. But here the number of divisions value increasing, so that least count value reducing. The least count value reducing means accuracy increasing. That is the meaning. Okay, so whether it is possible or not? Yes, for increasing accuracy is possible, but highly difficult to take the reading, to observe the reading, because our eye resolution power is less. So this question, B question, is theoretically okay. Theoretically okay, but practically it's not okay. Okay, that is the answer for this question. The increasing accuracy, that is fine, but highly difficult to take the reading. Okay, so it is theoretically okay, but practically it is not possible. Okay. Next one, the mean diameter of thin brass rod is to be measured by a vernier caliper. Why is a set of 100 measurement of the diameter expected to yield a more reliable estimate than a set of 5 measurement only? Okay, sure. Say for example, they mention thin brass rod. Okay, not that much thin. Okay, for example, let's take this rod. Okay, so I want to measure what is the diameter of this rod by using the vernier caliper. Okay, right. Now I am using the vernier caliper. You know, in the laboratory you are going to take, or you know already. Okay, in different places we have to measure. Okay, so moreover we are taking the 5 set reading only. Okay, but comparing with the 5 set reading, if you take 10 times, we can get more accurate value. Suppose if you do the 100 times, it is accurate value comparing with the 10 times observation. Okay, so in the questions also they mention why a set of 100 measurement of diameter expected to yield a more reliable estimate than a set of 5 measurement. About 5 measurement over 100 times measurement is best. Why? That is a question. Say for example, now I am taking the reading 100 times, okay, by using vernier caliper. So I take reading from here, 1 set reading, 2 set, 3rd, 4th, 5th, 6th, 7th, 8th. So like the different places. Okay. Suppose 8th reading I take. While taking the 9th reading, maybe some disturbance due to some dust or otherwise something. Okay, something. So I have to measure. I have included that also. Okay. So for example, it is a rod. It's a rod. So now one dust or something here. Now I have to measure this also, including that disturbance also I measured. In some place, actually if you focus, this rod is not uniform. Okay, see that this rod is not a uniform. It's not a uniform surface. Okay, so here somewhat. Okay, so just you observe that it's not uniform. Okay, so if you observe in some place some extra particles are there, in some place less particles are there. Okay, so if you focus, you feel it is less. Okay, if you focus here somewhat more particles, so I can measure that more quantity also, I can measure the less quantity also. So here some errors are there. That means you know that the error is occurred due to observation, that is random error. So due to this random error, maybe it is a positive 0.2. This is negative 0.2, so it will be cancelled each other. Okay, suppose if you take more than 100, I mean at least 100 reading means it is possibilities to cancel each other. The random error will be cancelled. Here positive value is there, here negative values, it will be cancelled. Okay, suppose if I take only 3 reading, only 4 reading, maybe it is a first reading, it is a second reading, then how we can get accurate value? Okay, so practically if you take more reading, okay, due to that random error, I mean I guess due to that random error, so it will be that cancel each other, maybe positive and negative, it will be cancel each other, so we can get more accuracy value. Okay, so if you increasing your number of observation, okay, that accuracy also increasing. Okay, so here in this question, that 100 times observation is best, we can get good result comparing with the 5 times observation. Okay.